So welcome to Electronics Lab. So we are in signal system lecture series. And today the topic of discussion is the discrete time LTI system. Okay. So in this discrete time LTI system, we'll see how a arbitrary signal, that is x of n, uh, can be means can be written in terms of the that is in impulse signal, that is del of n. So how the an arbitrary discrete time signal, that is x of n, uh, can be expressed as a unit impulse sequence, that is del of n. Okay. So you know that the LTI system, any system that obeys the linearity and the time invariance property is known as your LTI system. Okay. So let us check that. So how it can be done. Okay. So discrete time LTI system. So we have the linearity property and time invariance property. Actually, in LTI system, we have the it obeys the linearity and time invariance property. Okay, the response of the system with any arbitrary input can be expressed in terms of unit sample response of the system. So the response of any system to any arbitrary input, okay, that can be expressed in terms of unit sample response. Okay, that we'll see. Okay. So the general form of expression that relates the unit sample response of the system and arbitrary input signal to the is called the convolution. The response of the system to any arbitrary input signal, okay, uh, uh, that relates with the unit sample response is called the convolution, or this is known as the convolution formula. Okay. So we can able to determine the output of any linear time invariant system to any arbitrary input signal by using these convolutions. Okay. Let us see that how it can be done. So there are two things. One is the resolution of discrete time signal into the impulses. Then we will see what is the response of this discrete time signal. Okay. So any arbitrary signal, that is x of n, we wish to resolve into the sum of unit sample sequences. Okay. So let x of n is the infinite duration sequence. Okay. So this is our x of n. Any discrete time signal, okay, any arbitrary discrete time signal which is having the infinite sequence. Okay. So we'll see how this signal x of n can be expressed as term of del of n. Okay. So what is our del of n? This is our del of n, as we know that. So this is our del of n. So it is at 0 it is 1. Okay. At 0 it is 1. And we have all the other values at 0. Okay. So how the each sample we will see how each sample can be expressed as a del of n value. Okay. Suppose we can express this x of 0. Okay. So suppose the x of 0, that is the x of 0, how we can express in terms of del of n. Okay. So that can be done at x of 0 can be expressed in terms of del of n, as we have written x of n into del of n, where n equal to 0. Okay. So when n equal to 0, okay, when n equal to 0, that can be written as x of 0 and del of 0. Del of 0 equal to 1. Okay. So I can write x of 0 in terms of means del of n. Okay. Like if n equal to 0. This x of 0 equal to 0 for n is not equal to 0. Okay. Similarly, I can write this x of 1. So what it can be done? So x of 1 can be written in terms of with del of n. So it will be x of n into del of n minus 1. So if we have n value equal to 1, if n value equal to 1, this will be del of 0, that should be 1. So we can get x of 1. And if n is not equal to 1, it is 0. Okay. This is how you can express the x of 1, x of 0. Similarly, you can express x of minus 1. So x of minus 1 can be expressed as x of n into del of n plus 1. Okay, where n equal to minus 1. If we put n equal to minus 1, that would be del of 0. So it is, we can get x of minus 1. So this is how we can obtain the means x of n in terms of del of n. So let us see in details. So this is the, as I have told you, that the sample x of 0 can be obtained by multiplying the units impulse del of n. So it when we get x of 0, when n equal to 0. If we put here n equal to 0, we can get x of 0 because del of 0 equal to 1. Okay. So 0 or n is not equal to 0. Similarly, x of minus 1 we can get x del of n plus 1. For n equal to minus 1, that would be n equal to, if we put n equal to minus 1, that will be del of 0, which will be 1. Okay. So if we put over here del of minus 1, means n equal to minus 1, that will be del of 0. Okay. So del of 0 into x of minus 1. So del of 0 equal to 1. So we can get our x of minus 1. Okay. So similarly, so on so forth, x of minus 2 also can be written as x of minus 2 into del of n plus 2 for n is equal to minus 2. So if we put here minus 2, that will be del of 0. So we can get there x of minus 2. Okay. So similarly, x of 1 also can be written as x of 1 into del of n minus 1. So x, it will be x of 1 for n is equal to 1. If we put here n equal to 1, so if we put here n equal to 1, that will be del of 0. Okay. So x of 1 into del of 0. So it will be 1. Okay. So we can get x of 1. Okay. So this is how we can obtain the x of 1 values. Okay. So on so forth, you can get x of 2 also by multiplying del of n minus 2, provided that n equal to 2 over here. Okay. So we have means we have seen how to find out the x of n value. So this is all about some 5 sequences are there. X of minus 2 can be obtained by multiplying del of n plus 1. Similarly, x of minus 1 can be obtained by multiplying del of n plus 1. X of 0 can be obtained by multiplying means del of n. Okay. Similarly, x of 1 can be obtained by multiplying del of n minus 1, and x of 2 can be obtained by multiplying del of n minus 2. So this is our x of n. So for minus 1, minus 2 to plus 2. Okay. So if you want to find out your x of n from minus 2 to minus 2, then this is the means how it can be obtained. Okay. So for in general, you can see in general that can be obtained by x of minus 3 del of n plus 3, then del of n plus 2, and so on and so forth. Okay. This is x of n can be obtained by these expressions. Okay. So let us summarize this. So x of n can be written as summation of k equal to minus infinity plus infinity x of k del of n minus k, where n minus k del of n minus k equal to 1 for n equal to 1, and for n is not equal to k, sorry, n equal to k, 0 for n is not equal to k. Okay. So this is our expression for x of n. So we have obtained x of n in terms of del of n. So you can see this is the shifted version. So we have obtained x of n for using the del of n value. Okay. So this is our expression x of n. So now, so let us do some problem. So this is the problem. So you can see consider a finite duration sequence, that is the 2403. So originate actually 4. So resolve the sequence x of n into sum of the weighted impulse sequences. Means you have to find out what is x of n in terms of impulse sequences. Okay. So this n value equal to here n equal to 0. Okay, that is n equal to 1 minus 1. So I can write as x of n, it can be written as x of minus 1 into del of n plus 1. Okay, you can see here x of minus 1 del of n plus 1. Okay, similarly plus x of 0 del of n. Okay, plus x of 1 del of n minus 1. Okay, plus x of 2 del of n minus 2. Okay. So this is how you can obtain x of n in terms of del of n. Okay. So you can see x of minus 1 we have 2. So x of minus 1 we have 2. Then x of 0 we have 4. Okay. X of 0 it is 4. X of 1 it is 0. X of 3 it is, x of 2 it is 3. So this is a 4-point sequence. So now the x of n can be expressed as x of minus 1 into del of n plus 1, x of 0 into del of n, plus x of n into del of n minus 1, plus x of 2 into del of n minus 2. So you can put the x of x of n values, you can get your answer. Okay. So this is the x of minus 1 value, this is the x of 0 value, this is the x of 3, okay, x of 1, that is 3. So sorry, x of 1 equal to 0, so it is 0. X of 2 equal to 3, so this term will be finished. Okay. So therefore answer will be 2 into del of n plus 1 plus 4 del of n plus 3 del of n minus 2. Okay. So this is how we can obtain the x of n in terms of impulse sequences. Okay. So any impulse any actually x of n discrete time signal will be given, arbitrary such signal. You can express this x of n in terms of the impulse sequence. So weighted impulse sequence means these are the weights. These are the weights 2, 4, 3. These are the weights. So any impulse means anyway in arbitrary input sequence. This is the discrete time sequence can be means expressed in terms of the sum of the weighted impulse sequences. Okay. See the okay. So in the next lecture we'll see how the response of the system to these inputs. Okay. So that's all. So thank you for watching this video. If you have any doubt, please free to ask me in the comment section. Okay. So thank you all. Have a nice day.